In this problem, we are given a charge of 5 microcoulombs and position A, which is 40 centimeters away from that charge, and a position B, which is 6 centimeters away from A, and the angle between A and B is 60 degrees above positive x-axis. And we have a test charge Q from infinity that moves to A. And our first problem is asking us to find the voltage at A relative to infinity. So the voltage at A relative to infinity, we could use the voltage electric potential energy equation from infinity to A, which is written as the change in voltage from infinity to A is equal to the change in electric potential energy over Q, or electric potential energy final over Q minus electric potential energy initial over Q. And I'll remind you that the electric potential energy equation is written as plus or minus K Q test charge Q over D. From the D is the distance between the two charges, the test charge and the charge Q, which is 5 microcoulombs in this problem. So to find this change, we could rewrite this as VA minus V infinity, and that's equal to 0 usually. And we could plug this into the electric potential energy expressions that we written here, which is plus or minus K times Q times test charge Q. And the distance here is 40 centimeters. Remember, this is the initial and this is the final. So the distance between the two charges, the test charge and this charge, is 40 centimeters or 4.4 meters. I'm not going to write the units. Over Q minus plus or minus K times Q, and the distance is from infinity, so we write that as infinity over Q. And remember, any number divided by infinity is equal to 0, so this, we could write it as 0. And we can cancel out Q here. And to determine the plus or minus, test charge Q is positive and the charge we're working with is also positive. So they have the same polarity, so we're working with the plus sign in this equation. Now we could plug in our values. And we get voltage at A is equal to 1.13 times 10 to the 5th volts. Now for voltage at B relative to infinity, we realize that the initial part of this equation that we're going to use for voltage B as well is 0. So we could just ignore the initial like we ignored it here because it'll be 0. So we could just rewrite this as VB equal to plus K times Q times test charge Q over, we don't know the distance between D and B right here. We'll just write it as dB for now over Q. And the Q cancels out. And the plus stays the same here and here because the polarity doesn't change. So how do you find dB? I'm actually going to redraw that whole I'm going to redraw the diagram. So this is A, this is B, and this is 40 centimeters. This is what we're trying to find. And this is a 60, 90 30-degree triangle. So if we know that this is 6 centimeters, then the shorter side would be 3 centimeters, and this side would be 6, 3, square root of 3 over 2, which is 5.2. So now we could do the Pythagorean theorem, square root of 40 plus 3, 43 squared, plus 5.2 squared, and we get 43.3, which I'm going to approximate as 43 centimeters. So now we could plug in our values. Over 0.43, and that is equal to 1.05 times 10 to the 5th volts. Now for C, we're asked to find the change in voltage from A to B, which by definition is equal to voltage B minus voltage A. So it will be what we found in B, 1.05 times 10 to the 5th volts, minus what we found in A, 1.13 times 10 to the 5th volts here. And this is equal to negative 1,000 volts.